Hi everyone. Welcome to join our CPR 2020 workshop on adversarial machine learning in computer vision. My name is Sihan Xie, and I'm co-organizing this workshop with Xingyun Chen, Songbai, Bo Li, Kaiming He, Feifei Li, Luke Wangu, Victor, Dan Song, and Alan Yu. Our workshop is sponsored by DeepMind. Before we get started, here are a few tips for better attending this workshop. First, we are recording the whole event. So after this workshop, we will make the video publicly available. Second, all audience are muted by default. But during the panel discussion, we will unmute some audience to let them ask questions. Third, please do not turn on your video during the workshop. For asking questions during the workshop, we provide two ways. The first way is directly using Zoom. You can click the chat button there and ask anything you want. The second way for ask question is by using Slido. The link of Slido can be found at the external website of our workshop. You can ask and vote your questions there. So let's move on to the main content of this workshop. We all know that deep learning is pretty successful in computer vision. For example, we have two very popular datasets in computer vision. One is ImageNet classification dataset, and another is Pascal detection dataset. But in the old days, these two datasets are pretty challenging for computer vision researchers. For example, without using deep learning on ImageNet, the best result is only 74.2 top 5 accuracy. And for Pascal object detection dataset, the best results is only 40.9 mean average precision. But with deep learning, this result can get greatly improved. For ImageNet, the state-of-the-art model now can get 98.7 top 5 accuracy. And for Pascal detection dataset, the state-of-the-art result is 90.5 mean average precision. However, deep learning models are not perfect yet. They still have a lot of problems. The first well-known weakness is that they are fragile to adversarial attacks. It is worth noting that adversarial attacks not only can happen in the digital world. Researchers also show that such attacks can reliably fool deep learning models in the real world. Besides adversarial attacks, deep learning models are also poorly generalized to images that may not well covered in their training dataset. For example, the challenging outdoor conditions such as fog, rain, and snow may cause troubles to self-driving cars, as these weather conditions are not well covered in the current self-driving training dataset. Deep learning models are also very sensitive to occlusion, which is a fundamental aspect of nature images. As shown in these examples, there are a lot of cars here there, but deep learning models can only able to detect 3 of them. In today's workshop, we bring 9 experts on discussing these problems from the perspective of adversarial machine learning. They are Professor Alan Yu from Johns Hopkins University, Professor Alexander Madry from MIT, Professor Jelens Fernandez from UW-Madison, and Professor Matthias Besky from University of Tübingen, Dr. Lauren van der Matten from Facebook AI Research, Dr. Pingyu Chen from IBM, Professor Chuhui Xie from UCLA, Dr. Boqing Gong from Google, and Professor Thomas Dietrich from Oregon State University. Our workshop is a 4-day workshop and is divided into 2 sessions. In the morning session, we will first hear the talks by Professor Alan Yu, Professor Alex Madry, Professor Jelens Fernandez, and Professor Matthias Besky, followed by our panel discussion. And then is the poster session. Please note that all accepted papers will be presented in the poster session. In the afternoon, we will hear the talks from Dr. Lawrence van der Matten, Dr. Pingyu Chen, Professor Chuhui Xie, Dr. Boqing Gong, and Professor Thomas Dietrich, and followed by the panel discussion. Similarly, after that, we will have the poster session. Here, all papers will be presented there. Next, I will briefly talk about the submission statistic of our workshop. We received a total of 47 submissions, and most of them you can see in this bar chart lying in the advanced attack and defenses. Out of these 47 submissions, we accept 24 of them, with 11 papers on attacks, 6 papers on defense, 1 paper on application of adversarial machine learning, 1 paper on representation learning, 2 papers on explainable AI, 2 papers on theoretical adversarial machine learning, and 1 paper on GAN. Next, we will announce the best paper award of our workshop. Our workshop is sponsored by DeepMind. First, we are excited to announce that improving the affordability of robustness training for DNNs won the DeepMind Best Paper Award. The authors are Siddharth Gupta from UIUC, Parajat Dubey from IBM Research, Ashish Verma from IBM Research. Please join me on congratulating these authors. Next, for the DeepMind Best Extended Abstract, the award paper is on certified robustness against the backdoor attacks while randomized smoothing. The authors are Binghui Wang, Xiaoyu Cao, Jinyuan Jia, Neil Gong, all from Duke University. Again, please join me on congratulating these authors. We also have selected 8 people for travel award for covering their CVPI registration fee. There are Tianfu Wu from NCSU, Natia Ruz from Boston University, Jiawei Chen from Boston University, Sarwanti Adapali from Indian Institute of Science, Quentin Bonillo from CEA List, Jia Chen Sun from Michigan University, Kartik Gupta from Australian National University, Li Gonghan from Rutgers University. Lastly, on behalf of the organization committee, I want to say thanks for our amazing program committee. Thank you so much for your efforts on reviewing papers.